Hey guys, it's Nakmi here, bringing you another Integrated 1 math video. Today we're going to be talking about solving system of equations by elimination, right? I promised another method for solving these guys. And sometimes when you're solving these systems, substitution just doesn't cut it. It makes a little bit more work. It will work, but it's just, not as easy as this method. Elimination you might also know as addition or subtraction method, because you're literally going to be subtracting or adding these equations together. I like calling it the elimination method though, because when you add these two equations together, your goal is to eliminate one of the two variables that you have in your equations. So for example, right here, I have 2x plus 3y is equal to 9, and 5x minus 3y is equal to 5. And you'll note that the variables are all lined up in the correct location, and the constant term is on the other side of the equation sign. Doesn't necessarily have to be set up this way, it's just traditional and makes it a little bit easier. Also note that you have a positive 3y on the top equation, and you have a negative 3y on the bottom equation. Here's the thing. You are allowed to add equations together as long as you combine like terms correctly. And once you do that, you get a new equation that hopefully will be easier to solve. In this case, I have a positive 3y and a negative 3y that when I add these two together, they will cancel each other out. See this? Positive 3y and a negative 3y ends up becoming a 0. And I'll just add everything else together. 2x plus 5y is going to, 2x plus 5x is going to give me a 7x. And on the other side, 9 plus 5 is going to give me a 14. You see that? The 3y's are gone. And I end up with this new equation that's 7x is equal to 14. And that's a lot easier to solve than what I had before. I get this new equation here. Go ahead and divide both sides by 7. You end up with x is equal to 2. Right? That's half of your solution right there. To get the other half, you simply have to take this answer that you got, x equals 2, and substitute it back in for x. And it doesn't really matter in which equation. It could be the first equation or the second equation. I'm going to go ahead and substitute back into the first equation. And instead of a x, I'm going to write down here, it's 2 times 2, right, which is coming from this answer over here, substituted in for x, plus 3y is equal to 9. And yeah, you get this another equation, the same equation, but solve it for y. 4 plus 3y is equal to 9. Subtract 4 from both sides. Nice little multi-step equation here. 3y is equal to 5. Divide both sides by 3. You end up with y is equal to 5 over 3. And that's it. That's your answer for this system of equations. These two lines that if you were to graph cross each other at the point 2, 5 over 3. That's the answer that they both have in common, right? It's a nice method, right? It's a quick method, but only if your equations are set up correctly and your variables line up to the point where it's easy to eliminate each other, right? You're not always going to have problems like that, but when you do, it's pretty nice. It's pretty sweet if you have this method. Here, let me give you another example where the two variables are not exactly the same. Let's say I have here 5x minus 3y is equal to negative 9, and 4x plus 3y is equal to negative 11. If you guys note, you have here a 5x and a 4x. When I add these two together, it's just going to give me a 9x. So those guys do not eliminate each other. I have a negative y and a positive 3y. When I add those two together, I'm going to get a positive 2y, right? That's not going to eliminate each other. So that doesn't help us. We end up with another equation with two variables still there. So it doesn't help us. It doesn't eliminate. So you have to do a little bit of work on this problem. So here's what I'm going to do. I'm going to pick a variable, either the x or the y. And some teachers are going to tell you, pick the one that's easier. It's a little difficult your first time doing this, so you're not going to know which one's the easier one. So I suggest that you just pick a variable and you go with it. Don't overthink it. Don't think like, oh man, I should have went with the other variable. It would have been easier. With practice, you'll be able to figure out which one's the easier variable. But for now, just pick one variable and go with it. I'm going to pick the y's. All right? My reasoning, though, is because one's already negative and the other one's positive. So they're opposite signs already, so when I add them, if they are the same, they'll cancel out. That's my reasoning. But again, don't let that worry you. Just pick one variable and go with it to try to eliminate it. So I'm going to go ahead and try to eliminate these y's, right? In the top, I have a negative 1y, and in the bottom, I have a positive 3y. What I can do is actually multiply numbers to an entire equation, right? And I can easily turn a 1 into a 3 just by multiplying the entire equation by a positive 3. See here? when I multiply a 3 into that 1, it'll give me a negative 3. And that will allow me to cancel it out with the positive 3 in the bottom equation, right? So the only problem is when you do this, you have to make sure you multiply it to every single number. That way you don't get any errors. It keeps the equation true. So I have here 3 times 5x is going to give me a 15x. 3 times a negative 1y is going to give me a negative 3y. And 3 times negative 9 is going to give me a negative 27. Okay? That's my new equation for the first one up top. The bottom equation, I didn't really change anything, but I'm going to rewrite it over here so it'll be easier to line up and add the two equations together. So I'm going to go ahead and write this down here. Now I'm going to go ahead and add these two equations together. You'll notice that the negative 3y and the positive 3y will cancel each other out. They will eliminate each other. 15 plus 4x is going to give me a 19x. And this is going to be equal to negative 38. Again, you get this new equation with one of the variables eliminated. They're gone. It's no longer here, right? And you'd have a simple equation that you can just solve for right here. I'm going to divide both sides by 19. And you end up with x equaling negative 38 over 9, which I believe is a 2. Again, this is half of your answer. You take this negative 2 and you plug it back into x, into either one of these equations. You could, heck, you can even plug it into the equation you modified, and it should give you the same value for y, right? That's pretty much it for elimination. You just got to make sure that you pick one variable and you decide to eliminate it, okay? Sometimes you'll have to do a little bit more work. You might have to multiply both equations by a particular number, and that's not that much more, right? You just pick which variable you want to get rid of. So in this case right here, I have 2x minus 3y equals 8, and I have 3x minus 7y equals 7, right? I seem to be on this mode of eliminating the y's, so I'm going to go ahead and eliminate these y's right here. Why not? So I'm going to go ahead and have this negative 3y and this negative 7y to try and match up with each other so they can eliminate each other. Now, I can't really turn a 3 into a 7, right? 3 times 2 will give me a 6. 3 times 3 will give me a 9. So I can't really multiply by a nice whole number to keep everything whole. You could multiply by a fraction, but I know how most of you guys don't like to deal with fractions, so we're going to keep these as nice whole numbers. What's a number that I can get 3 and 7 to turn into very easily? Well, sometimes you can just multiply by the other number. 3 and 7 will give you a 21. So I can easily turn a 3 into a 21 and a 7 into a 21. Some of you guys might know that as your least common multiple. That's another lesson though. So I'm going to go ahead and multiply this top equation right here by a 7, right, to everything in here. And you end up getting 7 times 2 is 14x minus 7 times 3, which is 21y, equals 7 times 8, which is 56. Right? Yeah. And in the bottom here, I want to multiply everything by 3, but you got to be careful with this right here. When you multiply this by 3 to this 7y, you're going to end up with another negative 21y. Now, when you add these two equations together, negative 21y plus another negative 21y does not eliminate each other, right? They need to have one positive and one negative. So a quick fix for this is to multiply not by a positive 3, but multiply by a negative 3. So when you multiply by a negative 3, negative 3 times negative 7 will give you a positive 21. That way, your y's cancel out. Now make sure you multiply everything by that negative 3. So you end up with, in the bottom here, negative 9x, right? When you multiply these two together. And on the other side, you have equals to negative 21. Add these two equations together. The y's will cancel each other out. They will eliminate each other. And you'll end up with, let's see here, 14 minus 9x. What's that? That's going to give you a 5x. This eliminates each other. And you end up with 56 minus 21, which I believe is 35. And let's just to finish it off, you end up with x equaling 7. All right, that's pretty much it for the end of this video. I hope that you found it helpful in doing the elimination method or the addition/subtraction method. That's pretty much it for this section. Hopefully you guys will come back for other future videos. I'll see you guys later.